let's get started. Will help me fill this table. The first element here, hydride. Tell me formula and valency for hydride.
So H minus 1 minus.
Okay. Hydroxide. Anyone can. Okay.
So OH minus.
OH minus. Fluoride.
F minus.
F minus. Chloride.
Cl minus.
Bromide.
Br
minus.
Iodide.
I minus.
I minus. Very good. Permanganate.
It's KMnO4 if I'm not wrong.
That is potassium permanganate.
Okay.
So in that, what is permanganate? I think leaving potassium, everything else is permanganate.
Yeah, it's I guess
MnO4.
yeah.
Oh, HCO3 minus.
And what is valency like for permanganate? MnO4
Minus I guess.
minus 1.
Yeah, minus. Basically -1, but okay.
-1, yeah. So minus or -1, yeah, correct. So okay, in fact, I've actually just written monovalent electronegative ions together. So I think everything which is in this list is -1 only. Okay, so bicarbonate,
HCO3 -1.
HCO3 -1. Bisulfite,
HSO3 -1.
HSO3 -1. So bisulfite is like a sulfide with an additional hydrogen, but with a -1 valency. Like, okay, maybe let's do together here. What about sulfite? I'm just going to the other side. Sulfite here.
SO3 -1. I mean, yeah, -1.
No.
-2. My bad. It's 2. My bad.
Yeah. So it's -2. Okay, so let's finish this. Sulfate is similarly SO4 2 minus. Bisulfate is HSO4 -1. Okay, next nitrate.
NO3 -1.
This is NO3 -1.
The next one is NO2 -1.
NO2 -1. Okay. Eliminate.
It's I guess it's ALO3 -1.
Oxygen is not correct. Parisi, you're familiar with eliminate? Like, do you know what is valency for eliminate?
So valency is 1 only.
And formula?
So I think it's ALO2, I guess.
ALO2. Yeah, ALO2, not 3.
Okay.
Okay, let's complete the easy ones first. Carbonate. Do you know carbonate?
Yeah, it's CO3 -2. CO3
CO3 -2. Okay. Parisi, what about sulfide?
So I think SO something.
No. Anaya, what is sulfide?
So I think it's S minus.
Just a S.
2
Sulfide is just a S, 2 minus.
Sulfide.
Okay. How about oxide?
It's O2-.
Okay. Zincate.
Zn2-.
Zincate is
Yeah.
ZnO2.
O2-.
-2.
Yeah.
Okay. What about dichromate?
So
CrO7 2 minus, I think.
Cr2O7. Dichromate is Cr2O7. 2 chromium and 7 oxygen. With the 2 minus sign. Okay, we left acetate over here. Familiar with acetate?
Can I try? I read in one of the books. I'm not sure if it's right.
It's okay. You try.
So C2H3O2 -1. Is it right?
-1 is right.
I just told H3 without H5. My bad.
H3 is actually right. I heard it wrong. I heard it wrong. That's why. Yeah, that's what I was actually thinking. So H3 is right. Okay.
We haven't studied this, but I saw it in some chemistry book of my seniors. So
It is. You will come across this probably not this year, but next year. Acetate. It's a very common example. You might even come across it this year in some places.
isn't it O2?
Actually, the formula is like this: CH3COO -1.
Okay.
Okay. This you've condensed and written like this. So C2H3O2 minus. Yeah. So both are correct. But most likely you will see acetate written like this: CH3COO -1. Heard about thiosulfate?
Sir, I've heard. It's some S2 S2O3 2 minus.
Okay,
Probably. I'm not sure actually.
it is S2O3 2 minus. Yeah. Nitride. What is nitride?
And two.
N3.
Sir, N3
N3 minus.
minus.
See, here I will like to help you understand one very important pattern. Wherever you see ide, like leaving this exception of hydroxide, leave that. If you see ide, like hydride, fluoride, chloride, bromide, iodide, like whichever ends with ide, okay? Even here, oxide, sulfide, or nitride. In all of them, you just see the single element is there. Like, for example, in fluorine, it's only one F with a minus one. In chlorine, it's just chlorine, okay? Just a chlorine with a minus one. In bromide, it is just a bromine with a minus one. In iodine, it's just a iodine with a minus one. In oxide, it is just oxygen with a minus 2. Now the valency changes there, but see that there is only single element. Wherever you have a ide, it's only one single element with some valencies. Okay, similarly, sulfide is S2 minus. Nitride, because nitride has 5 electron in the valence cell, like nitrogen has 5 electron in the valence cell, it needs 3 more electrons, so it's N3 minus. Similar to nitrogen is phosphorus. So similarly here, phosphide,
P3 minus.
P with a 3 minus. Good. Yeah. Phosphate, this is PO4 3 minus. Carbide, like when carbon takes electron, it's known as carbide. So carbon has valency 4, so it takes 4, C4 minus. Okay.
Okay, I guess.
Sneha, dichromate,
Cr2O7
valency
minus 2, I
minus
guess.
2.
Yeah.
Anaya, you'll go second.
Okay, sir.
Anaya for you, zincate,
So ZnO2 minus.
minus 2. Okay. Next, Parisi,
Yes, sir.
can you tell me phosphide,
1 second. Phosphide is P.
P
3
with
minus.
valency
3 minus.
3 minus. A chemical formula represents the composition of a compound. The elementary steps in writing a chemical formula is we first write the symbol of the elements. Okay, then we write valency of each element. Like we write the symbol of the radical along with the charge, and then we do cross multiplication to arrive at the formula. Let's see, sodium chloride.
NaCl2. No, NaCl. Only NaCl.
Only NaCl because sodium has plus one and chlorine has plus one. So even if you do cross multiply, you get 1 is to 1. And we can ignore the 1, so we write NaCl. Okay, so moving to the next topic, like forming chemical formulas, category wise. Okay, so one where the positive has 1 plus and negative also has minus 1. Let's take such example, not the one which I did. Can you give me example of a cation with plus 1 and a minus 1? Not the one I did just now. Any other cation with a plus 1.
Potassium.
Potassium, good. Potassium is plus 1. Like an anion with a minus 1 valency?
Iodine, I guess.
Iodine. But iodine as a minus is known as? Like iodine as 1 minus?
Iodide.
Iodide. It's not iodine. Okay, so
Sorry, iodide.
potassium and iodide. So if both have 1 and 1, then see whenever
They,
they have same valency,
I just told they remain K and I.
they remain Ki. If so they have same valency, you just cancel it and you can write it as Ki. One time. Okay, let's take another example where cation and anion both has 2 plus and 2 minus.
So magnesium.
Zincate.
Zincate, okay, ZnO2. Okay, so now if they have 2 and 2, what do we do?
So cut both of the twos
Just cut both
and the
of them.
minus plus.
Yeah, so if both has 2, you just cut and write Mn MgZnO2. Okay, what if they have 3 and 3?
So aluminium.
Okay, very good.
And maybe phosphide.
Nitride.
Nitride, okay, very good. What do we do here?
It remains ALN because you can cancel out 3 and 3.
So ALN. So our learning from these three examples is, okay, if cations and anions have same valency, we can just cancel the valency.
if you can't cancel the same valency if it's two positive signs or two negative signs.
Yeah, that's what I meant. Like if they have same valency, like plus and minus, same valency, opposite sign, I should have written. Like if both have 1 and 1, you can cancel it. If both have 2 and 2,
Okay.
then you can cancel it. Both have 3 and 3, then also you can cancel it. Clear?
So the sign doesn't matter.
See here, I would like to tell you one thing. Like any chemical compound, a molecule consists of a positive and a negative radical. So it's not possible that we combine two positive or two negative. So we always combine a positive with a
So I
negative.
understand.
Okay. So a cation combines with an ion in all the cases. Okay, this way we can remember the valency. So plus one. Another example can be lithium. Minus two. We saw plenty just now. One example of minus two. Yeah, anyone can tell. Minus two.
Bromide? No, bromide is one. My bad.
So zincate.
Zincate we just used in the previous example.
Oxygen,
Oxygen. What is oxygen? Two minus known as
oxide,
oxide. Yeah. So lithium and oxide. Yeah. So in this case, they have different valencies. The only way to simplify this is by crisscross method.
So it's Li2O, right?
Yes, you're correct. So this number two, right? It comes here. So it becomes Li two, and O gets O is one logically. Okay, here in this we don't have lithium. So what we'll do, we'll just bring another element with plus one charge. So let's bring potassium. From the other side, we bring oxygen. Okay. Now, see, potassium has one plus charge, means potassium gives one electron, while oxygen has two negative charge, means it's taking two electron. If we try to merge them, you see that oxygen doesn't get enough electrons, right? Because its valency is two, so it likes to take two, while potassium is giving one. Therefore, to balance this give and take, we need to bring two potassium. So the one which has one charge is two in number, and the one which has two charge is one in number. Make sense? So ideally, the number is like that, 2 and 1, so that the give and take of electron is same. Okay, let's try 1 with 3 now. Okay, lithium is over now. Let's bring another one. Acha, can you give me example of a cation which has more than one element in it? Like a polyatomic cation?
Sir, I think ammonium is one, but I'm not sure.
Yeah, ammonium is one. That's correct. So it's NH4 plus. Okay, and then with a negative 3 charge?
So phosphate and phosphide.
As Anaya said, you can use phosphate. No, it's PO4 3 minus.
Oh, okay, Anaya, we can do that. So yeah, phosphate, PO4 3 minus. Okay, so let's finish the formula quickly then. 3 comes this side and 1 goes to the other side. Now, see here, I would like to tell you one more thing. Maybe you know it already. See, whenever you have polyatomic ions, radicals or ions, in that case, and if you want to put a number 3, like 3 times, it is important that we keep a bracket around the polyatomic anion. Okay,
So
if
it's
we put,
NH4 3.
yeah, it is NH4 inside the bracket, and then we put a whole 3.
And
This,
then,
yeah, this we do for any polyatomic radical if we need to put number 2 or 3. And PO4, this only has a number 1, so no need to put a bracket. Okay, so we saw 1 with 2 and 1 with 3. Okay, let's move forward. Let's try 2 with 1, and then we'll try 2 with 3.
so you can take calcium.
Calcium
We
is
have
2 plus. Very good. And 1 minus?
fluoride.
Hydroxide.
Okay, hydroxide sounds good. Okay, hydroxide. So again, crisscross for calcium, just one. So
OH.
we, okay, OH, we put bracket or not?
Yeah, we do put a bracket there because it's outside.
It's
So it's what?
polyatomic, right?
Yeah,
There
it's
are
what?
two atoms, so we put a bracket. 2 and 3.
2 and 3. What 3? No, you can't.
Okay, 3 I'll help you here. Phosphide is another 3 minus. Phosphide, like nitrite, phosphide, phosphate. Just help me with a 2 plus, a new one.
so zinc,
Zinc is 2 plus, very good. So now let's cross multiply. Okay, so it is Zn. Okay, on Zn we put number 3. Here bracket is not required because it's only Zn, a single element. Uh, then even phosphorus gets number 2. That's it. Let's try 3 now. 3 plus with a 1
Aluminium.
with a 1 minus, and 3 plus with a 2 minus. Okay, so aluminium is one of them. Very good.
Did we use chloride as 1 minus?
Yeah. Let's try like polyatomic chloride. I think we already used sodium chloride. I think that was the first one. Some polyatomic bigger ones we used.
HCO3.
HCO3 hydrogen carbonate is a good example. So HCO3 1 minus. Okay, so what is final formula?
So Al HCO3 in brackets and the whole thing thrice.
The whole thing
The
thrice.
HCO3.
Good. Okay, a 3 plus with a 2 minus. What other than aluminium is 3 plus?
So is chromium 3 plus? I don't
Yeah,
know where
yeah, good.
exact
That's
words.
a good example. Chromium is 3 plus. Okay, chromium with 2 minus.
So carbonate.
Okay, didn't. Okay, let's use carbonate. I think we did not use. So chromium and carbonate. So what's the final formula? Again a crisscross. So
So
two.
it's Cr2, CO3 in bracket and thrice. Whole thrice.
Oh, very good. What if I have carbon and oxygen? Like oxygen as oxide. Okay, okay. I think you understand that valency comes from the electronic configuration of the element. Carbon has 6 electron in the valence shell, means its electronic configuration is 2, 4. You're familiar with this?
Yeah.
So it has 4 electron in the outermost cell, means in the second cell there are 4 electrons. Now this carbon, it has two tendencies. Either it likes to gain 4 more electron and become a carbide anion. So that is carbide, C4 minus. Okay. But sometimes the same carbon donates 4 electron and it becomes a carbon cation. So it can either take or give because it has 4. So it has both valencies, plus 4 and minus 4. What is oxygen valency? 2 minus.
2 minus.
Oxide is 2 minus. See, in this case, carbon is plus 4 and oxygen is 2 minus. Oxide is 2 minus. Okay. I couldn't have taken carbide with oxide because both are negative. So negative, negative can't combine. So if carbon needs to combine with oxygen, the only way of doing that is carbon gives and oxygen takes. So carbon becomes positive, oxygen becomes negative. Now let's try to write this formula. Like this has 4, this has 2. Now can you see they have common factor 2 in them?
So it becomes CO2.
Yeah. So see if you have like 4 is a multiple of 2. So these are some like some exceptional cases. So in such case, we just divide the two valency, make it 2 and 1, and then do cross multiplication. So if one number is multiple of the other, which happens in some real cases like this 4 and 2, then you cancel the valency, write the simplest ratio, and then do cross multiplication. So this is CO2, and I think this we are familiar with. We know carbon dioxide is CO2. Correct? No confusion till here. Yeah. Barium sulfate. Let's practice these. Who would like to tell barium formula?
Sir, it's Ba2, no?
Yeah, it's Ba with a 2
Plus
plus.
2.
Barium with a plus 2, correct. Sulfate is,
I'm not sure, but SO4 2 minus.
yeah, that's correct. SO4 2 minus. Okay, here we just cancel them then. So the formula is BaSO4. Sodium chloride, this is easy. Okay, who will tell?
NaCl.
Oh, this is very easy. Okay, NaCl, 1 plus Cl minus, so NaCl. Okay, calcium bromide, Ca,
CFP2.
2 plus, and bromine
Yeah,
is
B minus.
Br
Br
minus
minus.
1.
Yeah.
Okay,
So it's
therefore
CaBr2.
Br2. Very good. Ferrous sulfide,
FeS2.
FeS, chromium sulfate,
A Cr2 SO4, I think.
CrSO4.
Yeah, Cr2 SO4. And the next one is CaCO3. Right.
is this correct? Cr2SO4?
Yes, so I just did.
So isn't it
You can
CrSO4?
cut off that. Oh, sorry. Okay.
No, we can't cut.
Why can't you cut? Isn't it 2 and 4?
No, chromium. It's not carbon.
Okay. So chromium is
Chro-
Cr only, no?
chromium is
Okay.
3 plus.
Cr2 plus, I
Three.
think. Oh, 3 plus.
My
Chromium
bad.
is 3 plus, and sulfate is 2 minus.
Yeah, yeah.
Okay, therefore this is
So then it's CrSO4 thrice. Cr2SO4 thrice. Sorry.
Yeah, Cr.
yeah. That's it. Calcium carbonate.
CaCO3.
Okay, both have. So sodium thiosulfate.
So it's S2O3 2 minus. I told you.
Thiosulfate is H2O3 2 minus. Very good. And sodium is Na plus. So the formula is Na2
S2O3.
H2O3. Okay. Next is stannic. Stannic is SN4 plus again, and phosphate is PO4 with a 3 minus. So on cross multiplication, we get SN3 and PO4 with a whole 4. All right. Okay. Let's see the next final example. Nickel bisulfate.
I
Okay. So
think nickel is Ni plus 2.
nickel is Ni plus 2. Very good. Bisulfate.
HSO4 2 minus. I'm confused.
HSO4 1 minus.
5 minus. My bad.
All the bisulfate, bisulfide, bicarbonate, they are all 1 minus.
Okay.
So this is Ni, HSO4, and then
Twice. Whole
twice.
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 Good. What is a chemical equation? A chemical equation is a symbolic representation of chemical reaction with help of chemical formula of the reactant and product in the reaction. The reaction can be represented by either a word equation or by a chemical equation using symbols and formulae. Okay. So have you seen a chemical equation before? Obviously you have. So chemical equations are basically representation of chemical changes in terms of formulas of the reactant and the product. So it basically tells us which element is combining and which element is formed, like what's the product. So what are the reactants and what are the products. A simple example of chemical equation represented with word equation could be, we can say carbon combines with oxygen to form carbon dioxide. Same thing can be written in form of like symbols. Symbol for carbon is C, symbol for oxygen is O2, and they combine to form CO2. Carbon is solid, oxygen is gas, and even carbon dioxide is gas. See, whenever we write a equation, chemical equation, we mostly first write them in skeleton equation or in a skeleton form. Skeleton equations are also called as unbalanced equation. So a chemical equation in which the total number of atoms on each side of the reactant and the product is not same. Okay, so the number of elements in on the reactant side is not same as the number of reactant elements on the product side. It is known as unbalanced equation. For example, nitrogen combines with hydrogen to form ammonia. So nitrogen gas combines with hydrogen gas to form ammonia gas. Okay, we can also write the state here. Why is it written N2 and not N for nitrogen? Why do we write N2 for nitrogen and not N for nitrogen?
So I think it's because of the diatomic.
Nature of the gas? Is it because of the diatomic nature of the gas?
Yeah.
That's true.
Yes, sir.
What do you mean by diatomic nature of the gas? It means two nitrogens are always
It's like two
together.
atoms form.
Yeah,
Yeah,
two
one minute.
atoms are always together in a molecule. Can you say with guarantee for every single nitrogen which is moving around you in your room? You understood my question. My question is like obviously atmosphere is full of nitrogen. So even the air which you have around you has nitrogen in it. There are plenty of nitrogen molecules moving around. So can you tell with guarantee that every single nitrogen which is moving in your which is present in your room are actually in pairs? Are
Yes, sir.
they're all in pairs. Okay, good. So that's what I want you
Yes,
to
sir.
understand. Like nitrogen present in atmosphere is always in diatomic state. Means every nitrogen is in pair. Like none of the nitrogen is alone. And same can be said about hydrogen. Every hydrogen is in pair. Therefore, whenever we write reactant, we always write them in the state in which they're present. Okay, so now see, the equation which you see on your screen is not a balance equation, correct? Because here the elements are not equal, like on the left side and the right side. And therefore, we need to balance this equation so that we have the same number of elements on either side. Balancing equation means we just add nitrogen and hydrogen in such proportion that we get this ammonia. Also, like nitrogen, hydrogen, and ammonia, we need to arrange them in such proportion so that the number of nitrogen element on left side is equal to number of nitrogen on the right side, and same goes for hydrogen. Do you know how to balance it? Can you quickly tell me the answer?
Does H2 become 3H2?
H2 becomes 3H2 and
Yeah.
NH3 becomes, okay. See,
Sir, I
basically,
memorized this stuff. I'm sorry, excuse me. I memorized this stuff. Is there any way to balance the equations, like any method or something?
we we are not supposed to memorize this step. How many you will memorize? This year you will have like I think it's like 80, 90 equations in your in your textbook.
Sir, I just remember, I just memorized it somehow. But like I legit never learned the method. I
See, there,
forgot or either never learned.
okay. See, there is no proper method, but they are hit and trial. Okay, so I cannot tell you that there is exactly the sequence which you need to follow, but with trial and error, we learn a pattern. See, when I write N2, what does that mean? That means there are two nitrogens. So I'll just try to break this equation and help you understand what N2 means. N2 means there are two nitrogen atom, right?
Yeah,
And H2 means
there are two
two
hydrogen atoms.
hydrogen,
Yeah,
and they combine to form NH3, means one
okay.
nitrogen with
Three
three
hydrogen.
hydrogen.
Okay.
Now see, logically, this and this can't combine to form this because the number of nitrogen and hydrogen is not same, but they can still combine in some other proportion to get exactly NC. So see, I know this one nitrogen requires three hydrogen, but here we have only two hydrogen. So I mean I need one more hydrogen, right?
Yeah,
Okay, but if you go searching in the atmosphere for one hydrogen, you'll never get one hydrogen because hydrogen always exists in pairs. Okay, so
yeah.
if you, it's like a buy one get one offer. Now this means this nitrogen is combining with this three hydrogen to form ammonia. But we also need to take care of the other nitrogen and the remaining hydrogen because everything must get balanced. So now what happens with the other nitrogen? Now this other nitrogen is looking for more hydrogens to combine. So this combines with one of this hydrogen and two more hydrogen from another molecule of hydrogen. So that nitrogen combines with these three to form another NH3.
Okay.
This way we get two NH3. Okay,
Okay.
and here see one, two, three. Three hydrogen molecule combines with one nitrogen molecule. So
Okay.
does balancing make sense? Why
Yeah,
are we doing
makes
that? Basically, the idea behind introducing three hydrogen and two ammonia is to ensure that the number of element is same on either side.
okay.
Okay, that's the idea. And if you keep this in mind, I think it's not that tough to balance it. A balanced chemical equation is nothing but the equation in which the total number of atom of each element in the reactant on the left side of the equation is same as the number of atoms of the in the product formed on the right side of the equation. So if every single element is same on either side of the equation, left side and right side, okay, that's what we did now, nitrogen and hydrogen. Then it is known as balance equation, is hit and trial method. So this method doesn't have a strict rule. Okay, like in this method of balancing chemical equation, trials are made to balance the equation by using the smallest whole number coefficient. Hence, this method is called as hit and trial method. So the rules which you can follow is you can count the number of times an element occur on either side. First, you just see which element is how many times, so that we can balance the elements which are not balanced first. An element with the least frequency or occurrence is balanced first. So this is second point which we can keep in mind. We'll try to balance those elements which has lesser frequency. Mostly you will find that in a chemical equation, metals have lesser frequency than non-metals. So if two or more elements have same frequency, we can try to balance the metallic element first. Again, I will just like to point out is you don't by heart these rules. Just these we learn through practice. And don't take this as a hard and fast rule. There will be a lot of small tricks which I'll teach you to balance chemical equation while balancing chemical equation. So, and I'm for today just we'll do a few easy ones, and then we can see more tough ones in the next class. Carbon and oxygen form carbon dioxide. Okay, I think we just did it. This is very simple. A carbon monoatomic plus oxygen O2 becomes carbon dioxide, CO2. Is this reaction already balanced?
No, I guess.
How many carbons we have on either side?
One,
Oxygen
two.
is already balanced. Okay, next, nitrogen. What is formula for nitrogen?
So N2.
N2.
Yeah.
See, whenever they say nitrogen, we take nitrogen in its molecular form because in nature, nitrogen is always present in form of N2. It's never present in form of like independent nitrogens are not found in nature. Free nitrogens. Okay, so we always take the reactant. Suppose a word equation is given like this. We always take a reactant in their natural state. Okay, same thing for oxygen. Oxygen is O2. Okay, formula for nitrogen monoxide is NO. All right,
So I think it's 2NO.
2NO. Good. That's it. Formula for calcium. Metals are
Ca.
all monoatomic, so they stay alone. Ca plus nitrogen N2. Okay, so calcium nitride. Formula for calcium nitride. Calcium is 2 plus, nitride is 3 minus, so it is Ca3
Three.
and 2. Is this balanced? No.
No, sir.
No.
Three calcium here. So that side also we need 3 calcium. As we said, like metals can be balanced first. So 3 there. Then nitrogen, oh, is already balanced. Like just the final few. Calcium oxide,
CaO.
CaO. Carbon dioxide,
CO2.
CO.
CO2.
You get CaCO2.
So yeah, is that balanced? Can you just one check?
So it's balanced.
It's already balanced.
Yeah.
Okay. Magnesium plus sulfuric acid. Magnesium is
Mg.
sulfuric acid. Heard the name?
HSO4, no?
So HC. Oh yeah, HC4.
No, not HSO4. H2SO4.
She's
Sulfuric
fine.
acid. Yeah, sulfuric acid is a hydrogen sulfate. Okay, it's like hydrogen and sulfate. So hydrogen has a +1 charge, right? So we get two of them and sulfate. Magnesium sulfate. This is okay. Both have valency +2 and -2. This is MgSO4
Plus H.
plus H2. Hydrogen is H2. Is this balanced?
Yes, sir.
It's already
Yes.
balanced. Okay, next one. Sodium reacts with water to form sodium hydroxide and hydrogen. Sodium reacts with water to form sodium hydroxide. Sodium hydroxide is
NaO.
NaOH.
NaOH plus hydrogen. Okay, let me do this one with you and I will teach you a trick which I use personally for this situation. Sodium is balanced. Okay, I don't worry about that. Then I saw this hydrogen H2 alone. Whenever I have this single molecule alone, okay, I try to balance that at the end. Okay, so next oxygen is already balanced. Hydrogen, this side we have two hydrogen. This side, here we have one hydrogen. Okay, I can't do much about this hydrogen because this is with NaO. So if I put any number here, even NaO will get disturbed. So I don't want to do that. Okay, but I can manipulate this. I need one more hydrogen from here, right? But here we have two. How to make two one? So I'm going to teach you a very strange technique. Okay, just try to understand. I'll put a half here. What is half into
1.
one? But can we leave it like this? No, we can't leave the equation like this. Then further to cancel the 2, no, I multiply entire equation with 2. Here 2 and 2 get cancelled, so just 1 H2. So the balance equation is 2Na plus 2H2 gives 2NaOH plus H2. Am I clear? Okay, Sneha, you understood what I said just now?
Yes, sir.
Okay. So this is how we solve these kind of equations. So you'll find such similar pattern. So it's all about practicing question. I think the equations which we did today were all simple. We'll see more complicated types. Okay, and it's all about practice. All right. I think that's enough for today. Okay, for the timing, tomorrow class is scheduled at the same time. So hope to see you there tomorrow. Thank you and bye for now.
Bye, sir.
Bye, sir. Thank you.
Bye bye.